let me request Dr. Tribhuvan and Kuldeep to show the report on camera. We are sharing the download link very shortly in the chat box, so all of you can download the report. So this is the report. I have managed to share the soft copy of the report with all the panelists so that they could go through the report and they could share their insights. Now, before I invite Dr. Richa to make her presentation, I request Dr. Tribhuvan to please introduce Dr. Richa to all of us.
Yeah, thank you, Atin. So Dr. Richa is currently a research scientist on an EPA-funded human biomonitoring project for Ireland at the UCD, Centre for Safety and Health at Work, University College Dublin. Previously, she has worked as a program manager at CSE in New Delhi. She led research and advocacy efforts on sustainable waste management with a focus on dumpsite remediation across India and Africa as well. Dr. Singh holds a PhD in environmental science and engineering from IIT Bombay, where her work centered on eco-friendly construction material derived from municipal and hazardous waste. She has been a visiting scholar at institutions like TU Delft, NTNU, then University of Texas, Arlington, and has received numerous accolades, including the BHU Gold Medal and the Research Excellence Award. A passionate advocate for sustainable waste management, Dr. Singh has represented and also presented her research globally, including as a TEDx speaker, and recently co-edited the book Solid Waste Management for a Resource-Efficient Economy, published by Elsewhere. Over to you, Dr. Richa.
Thank you, Richa. Over to you. You have roughly about 20 minutes to make your presentation. Thank you.
Okay, Atin, as you know, I'm very bad in time management. Would appreciate if you just remind me if like 5 minutes are remaining in my...
Sure, I will. Thank you.
So let me share my screen first. I hope my slides are visible to everyone.
Yes.
Yes.
Please
okay, and I'm audible. So yeah, first and foremost, thank you so much, Atin and CSE, for having me here in this very important discussion and for giving me the opportunity to present the key findings of our research on gainful utilization of SCF recovered from biomining of legacy waste dump sites in India. Although I live here, but my heart is still there, you know, and it's very weird to say that, but I just love doing work related to dump site remediation and the kind of massive mountains we have. Of course, it's not a matter of pride, but at the same time, there's a huge scope and there's huge scope to work and explore different, you know, opportunities which are there in dump site remediation and how we can contribute effectively in that. So I'd like to start with briefly going through the overall agenda of dump site remediation in India. So we know that like Government of India has its flagship program called Swachh Bharat Mission, and we are progressing through the second phase of SBM, which is also known as Clean India Mission, phase 2, and it's aimed at making Indian cities garbage free. There are two key focus areas under the SBM phase 2, which is first ensuring that there is 100% scientific treatment of all the streams of waste, which is very, very ambitious, but at the same time, it's extremely important because we make sure that no such further, dumping of waste takes place, and we are trying to make a transition from a linear economy model of development to a more circular one. So scientific treatment of waste, including C&D waste, plastic waste, organic waste, inorganic waste, all of that. And also, we are addressing the issue of sanitary waste and domestic hazardous waste. And the second important key focus area is the remediation of existing dump sites that we are having in our country. Now, a lot of efforts has been done so far, and a lot of efforts are underway in the Indian cities. However, still a substantial progress needs to be made before the completion of second phase of SBM. And for instance, if we look at the SBM dashboard, SBM urban dashboard, we can see that the total legacy waste quantity that we have to deal with is around 2,211 million metric tons of waste, which is lying in around 2,500 dump sites across the country, out of which, as of now, we have remediated 41% of it, which translates to around 913 million metric tons. And we still have to deal with around 1,300 million metric tons, which is 59% of the total legacy waste lying in the in the Indian cities. So as far as the land area is concerned, as of now, we have reclaimed around 30% of the total land, which was earlier occupied by legacy waste. And we still have to deal with around 10,380 acres of land, which is 70% of the total legacy wasteland, which is occupied by these, dump sites. So, so we can see that clearly there is a lot of efforts that needs to be done in this domain. And while, there's a huge pressure on the Indian cities to do this, and there is a target deadline also, which is 2025, 2026, which is the time when the phase 2 will end. Now, most of the Indian cities are facing, unique challenges in the dump site remediation process. So, and these challenges are not only confined to contractual or financial issues, but also operational in nature. For instance, selecting the right kind of contractor who can ensure that there is end-to-end disposal of, of all the recovered fractions. There is lack of disposal plans for recovered material, including segregated combustible fraction, as well as the inerts or the C&D waste or other fractions of the waste that we are getting. Also, there is no standard protocol or standard guidelines on what is going to be the end use of the reclaimed land. And other challenges as well. So here we will focus more on lack of disposal plans and what to do with the segregated combustible fraction that we are getting. And this is one of the most common challenges that is witnessed by most of the Indian cities. So, so to understand this, first of all, let us try to understand how the biomining takes place in India. Biomining means landfill mining. So first of all, the waste is excavated and then it is converted into equal size windrows to get more surface area, and then it is treated with some sort of bacterial culture or bioinoculum. Now, this is very interesting because I've not seen this in many other countries where such kind of treatment is done, because our landfills or the dump sites are receiving mixed waste, and around 50 to 60% of it is organic in nature. As a result, it is very heterogeneous. It contains all sort of waste. Even if we see the organic waste, it is having waste which is more than 10 years old. It is having waste which is mid-aged or also freshly disposed of waste, because most of the landfills here in India is still operational in nature. So it becomes extremely important for us to make sure that we convert this unsegregated waste matrix into a stable matrix. And afterwards, what we do is we sort this material, we do the size segregation, and it depends on the size of the landfill and the quantity of the legacy waste. For instance, if it is a small landfill, they often go with the, machines like stationary sorting machines like trommel screens. And if it is a bigger, a landfill site like Okhla, Ghazipur or Bhalswar, they adopt mobile sorting machines like power screens, etc. So after which, these are the three fractions that we get majorly. First is your C&D waste, the coarser particles, the finer particles, which we call it as fine soil-like material. And then the third fraction is the segregated combustible fraction, which is mainly primarily composed of plastics or the materials which should have considerable calorific value. So if we look at what could be the potential uses of all the recovered fractions that we are getting from landfill mining operations in India, first and foremost is like fine soil-like material. So typically used as a filler material in the low-lying areas. Also in construction activity like road construction, embankments. For instance, in case of Okhla, Delhi Municipal Corporation has a memorandum of understanding with National Highway Authority of India, and they are channelizing the fine soil-like material or the inert fraction to, for road construction. It can also be used in sanitary landfill construction also as a soil cover in landfilling. Now, soil cover in landfilling, so basically this is the principle that, or standard protocol that one should follow if one has adopted a scientific way of operating a landfill. However, that is not being like it's not very common to see in India, but soil cover is extremely important because it basically acts as a natural fire extinguisher and also isolates a waste from getting in touch or getting in contact with the surrounding environment. So this material can also be potentially used as a soil cover. And maybe as compost, I have used maybe because I'm being very, very cautious and careful while saying this, because we don't know, we are dealing with dump sites or landfills which could be more than 50-year-old, and we don't know what is the actual composition in terms of toxicity of the fine soil like material. So we have to make sure that those components are free from any kind of toxic metals or organic contaminants. And as of now, we do not have any standard for that. So that's why I think whatever standard is available, like FCO guidelines, we can follow. And if it is confirming that, then only it can be used for, as a soil enricher or maybe as a compost. But more or less, we are not endorsing that. We are just saying that can be used for as a filler material in low-lying areas or for construction material. So that's about the 70% of or 75% of the legacy waste fraction. And now we will talk about the challenges in segregated combustible fraction. So segregated combustible fractions basically includes combustibles like plastics. So in our study, what we have seen is the plastics, they primarily consist of single-use plastics like multi-layered or packaging material or carry bags, etc., textile waste, and other combustible materials. And it refers to the portion of waste from legacy dump sites identified and separated for combustion or thermal treatment and needs to be treated appropriately by thermal treatment. Why? Because if the SCF is lying in the dump site, I think we all are aware about the fire outbreaks that is happening in Delhi every summers. And during when this kind of material is, openly burned in such fire outbreaks, it can release noxious gases, very, very hazardous gases like dioxin, furan, oxides of nitrogen, sulfur, and carbon, etc. So it needs to be segregated, mined, and properly, appropriately treated in an environmentally sound and economically viable way. So to understand these challenges, what we did a small study with these broader objectives. To understand the composition and characteristics of segregated combustible fraction from few dump sites in Indian cities, we did this study. We sampled the SCF from 4 dump sites: Kuberpur dump site in Agra, Okla dump site in Delhi, Leh, Bomgar dump site in Leh, and Bhanwari dump site in Gurugram. So also to understand the comprehensive, we undertook comprehensive review of existing disposal practices in SCF in the country. It's just one which is co-processing, and we will get to hear from our experts, our panelists, on how it is done and what are the challenges. We also mapped the cement co-processing units in the country, because many times when we were doing this research on landfill remediation, the cities were asking about what are the nearest co-processing units where they can send their material. Of course, they were ready to even bear the transportation cost, but there was very few. I mean, some of the cities which were very remote, and it was literally very not so accessible for them to kind of transport the material. So we did the mapping, and for this, the approach that we adopted is we actually mapped, or we selected different co-processing plants which were registered on CPCB's EPR portal. The same approach we took for the waste to energy plants also, and on the basis of this, we made few recommendations that can be pursued in order to enhance the utility of SCF and create a win-win situation for all the stakeholders involved. So we adopted a very straightforward methodology, as you can see, sampling the SCF from different biomining sites. And for this, we just adopted the stratified random sampling. So we collected the samples from the heap of segregated combustible fraction from the sites where biomining was going on. And so out of the 4 sites, 2 were the sites where biomining was underway, and 2 sites, including Leh and one more, Kuberpur in Agra. They were done with their biomining operations, but they didn't know what to do with the RDF or the SCF, which is lying in their facility. So after that, we did the segregation of different fractions, and we used sieves of different sizes and also by hand picking. And then we quantified the inert content or the material which is not having calorific value. And for the plastics, textiles, footwear waste, what we did, we estimated the CV, moisture content, and sulfur. So these are the different categories. As you can see in the slide, we divided the entire segregated combustible fraction, including LDP, PET, different categories of the plastics, and then footwear waste, leather and rubber, plywood, etc. And there were few fractions which we were not able to identify like what exactly it is. So we kept it under the category of others. In our study, what we came across is there are few things that can go wrong. So many of the cities were coming to us and stating that our SCF is a very good quality. However, none of these co-processing plants are ready to accept that. So, and they were reporting CV as 6,000 or 7,000, something like that, which was so difficult for us also to believe. So in our study, what we did is we did the pulverization of the sample first, and then we tried to see what is the CV of each of the fractions, and then how it is affecting the overall calorific value of the sample. So we realized that heterogeneity is something which is extremely important, and that should be considered while doing the analysis of the segregated combustible fraction. And representative sampling is extremely important because if you are just picking 1 gram of HDP or LDP or carry bag or multi-layered plastic and then subjecting it for CV estimation using bomb calorimeter, it will give you misleading result, because it is possible that 30% of the SCF that you are sending is actually nothing but stones and inerts. So it's not giving you a representative value. And that's the reason most of the cities are reporting overestimated calorific value, because they're getting it done from the third party and they're not much aware about how the representative sampling needs to be done. And it affects the decision making. And also there are certain mitigation strategies like how this should be done. We have to go for labs which are NABL and MOEFCC accredited, and they should have clear understanding about how to sample waste in a dump site, because it's not like water or any other thing which is homogeneous, but it's very heterogeneous, and we have to make sure that we are getting something which is representative. So these are a few of the pictures that we took the sample to AATI laboratory in CSE, and we tried to see different fractions. We remove the inert fraction and see how much is the calorific value. And this is basically representing this is the compositional analysis of all the 4 dump sites that we sampled. As you can see, some of the highlights here, the inert fraction in Banwari, Gurugram is minimum, which is 8%, and the maximum you can see it. So this is basically ranging between 8% to maybe 32% or 34%. Why? Because it also, it depends on, and you try to understand here that if there will be higher concentration of or percentage of inert fraction or fines, this will negatively affect the calorific value. And the cement factories, they have the unit operations which can deal with or segregate these materials, but in that scenario they won't be, this would not be considered as a good feedstock for their plant. So these are the things, and this I'm talking about, this is not something I'm talking about, the sample was collected after sorting was done. So this was just segregated combustible fractions taken from different biomining sites. So apart from this, the other observations is, so most of 50 to 60% of the SCF is primarily plastics, that too low value plastics, category 2 and 3, which is not having, any value, carry bags, or we can call it single use plastics. And other fractions, predominant fractions are textile waste, footwear waste, etc., which is also having considerable calorific value. Now, one of the important findings here was, about this Okhla dump site. So initially, if you see in this slide in Okhla, the inert or fine fraction was around 32%, and this is before the installation of air density classifier. But when they found that the contribution of inert and fine fraction is much more than what they expected, they installed air density classifiers, and this has a positive impact on the inert and fine contribution. As you can see, it got drastically reduced to 21%, which is, so these kind of unit operations are extremely important to get good quality of segregated combustible fraction. So these are the CV which has been reported for each of these SCF samples collected from different dump sites. And as you can see, this the SCF of Okhla dump site is 3,298 kilocalorie per kg, the CV of this dump site, and for Leh it is 2,969. So the important point here which I want to highlight is, if you see Bandwari, it is 4,383. Why? Because the inert or fine fraction was just 8%. So the CV is compromised because of contamination, and the way you are doing the biomining operations, the different steps if it is followed properly, if the waste is segregated properly or sorted according to its size, then we can make sure that we are actually converting the recovered fractions are of good quality. It will become easy for the city authorities to channelize it for various gainful applications. So if we talk about available disposal treatment options for SCFs, we know that currently we are just sending the segregated combustible fraction to the cement co-processing plant. So the segregated combustible fraction from legacy waste contain contaminated combustible material, and that is one of the reasons. If you see the waste management hierarchy, recycling is something which is given more priority than thermal treatment, which is also known as recovery. So, but in this case, we cannot convert these plastic into anything reusable or anything, some plastic products, because these plastics are first single-use plastics. Second, these are contaminated. The other thing is, most of the things I think we have already discussed about it. So single-use plastics like carry bags and multi-layer packaging, category 2 and category 3 as per EPR policy, we have received these two kind of samples. Limited treatment option due to contamination level and material composition. And currently, there are two technologies which can be used: waste to energy and co-processing. And the rationale is thermal treatment and co-processing ensures complete destruction and environmentally sound disposal. However, we have to make sure that the emissions are under control and the combustion temperature is such that is ensuring that all the waste is completely destructed. Now, if we talk about co-processing, I think we will get to hear more about it from our panelists, but this is basically a process which is, we know that how cement manufacturing takes place. There are different steps involved, like procuring or grinding the raw materials like limestone, clay and shale, homogenization, which includes additional blending of the material, preheating. And if you see the fourth step, which is fuel here, conventional fuels are also used, and some waste material having good calorific value can also be used as conventional or as alternative fuel and raw material. For in this case, we are sending these combustible fraction, which undergoes a different they also have to install different unit operations in order to get the right kind of feedstock they want. That's why it comes at a cost, and that is the reason co-processing is not as simple as it looks like, that you just put everything, it will just get burned. So everything happens in a controlled condition, and they also need to invest in dealing with getting the right kind of feedstock. So, and then there
Richa,
is,
you have exhausted your time, Richa. Just try to wind up in another
do I
5
have
minutes.
5 minutes, or like I have completely exhausted?
No, you can take 5 minutes because it's important that you run through the presentation, because that will.
Okay,
Yeah,
so there are five very important parameters which are extremely important to make sure that the feedstock is of right quality. Size, ash content, moisture content, chlorine, sulfur, and net calorific value. I think we have already spoken about the calorific value. It should be more than 1500 kilocalorie per kg if we have to send it to waste to energy plant. This is also mentioned in our solid waste management rules 2016. And for I think for co-processing plant should be at least more than 2500 kilocalorie per kg. And then the chlorine content and sulfur content is also extremely important because they are corrosive in nature, and if the chlorine content is more than 1%, I think they have to make some modifications, or they simply can't accept that material. Same holds true for sulfur, as they are corrosive in nature. Moisture content and ash content is also different parameters which has to be given appropriate consideration. Now, if we look at the co-processing plants, as I mentioned, we try to map different co-processing plants which are there in India. And so the number is 80, and the capacity is around 11.6 million metric tons. And this is the annual capacity of the co-processing plant. Now, these are the co-processing plants which are registered on CPCB's EPR portal. So the states having maximum number of co-processing plants is Tamil Nadu, followed by Rajasthan, Madhya Pradesh, Telangana, and so on. Likewise, we did this mapping for the waste to energy plant also, and the number is 30. It's really difficult for us to believe it's actually 30 waste to energy plants are operational in nature. But this is what they have registered on CPCB's EPR portal. And apart from these two thermal technologies, one interesting plant that I saw was in Mulund dumpsite, and they have this 100 TPD plant for converting legacy plastics into RDF, which has higher calorific value. I think it's a grade 2 RDF material which can be supplied to not only to co-processing plants but also to different energy intensive industries. This case study is very interesting, and I just want to take 2 minutes, Atin, to talk about Prayagraj model. I think we have Ashish Tiwari sir who will talk more about it, but I think this is one of the classic model that we have in India. I remember once we spoke about, can we use EPR? Can we connect EPR thing to legacy plastics? Because we know that this is generally for dealing with fresh plastic packaging waste. But then actually Prayagraj did something like this, and which can be replicated in other cities, and it's an inspiration for every city across the country. So under the guidance of Department of Environment, Forest and Climate Change, Government of Uttar Pradesh, a tripartite agreement was signed between Prayagraj Municipal Corporation, Karosambo, which is a waste management agency, and Dalmia Cement to, create a EPR-led model for making sure that the segregated combustible fraction, which is generated from Baswar dump site, is appropriately utilized and transported to the co-processing plant. So basically, this model has successfully created a win-win situation for all the stakeholders involved. And also, one of the major challenges that cities are facing is they have to bear the cost of transportation. Now, imagine a city like Leh who has to transport the SCF to the nearby states. And considering the difficult topography, if they also have something like this, it becomes easier for them to kind of bear the cost or share the cost at least with the by using something like EPR-led business model. So this is how it takes place. So as you can see from the buzzword landfill site, biomining and sorting of the legacy waste is taking place, and whatever SCF is generated, it is transported to the nearest co-processing plant. Now the cost involved, the transportation cost is something which is mobilized. The funds for bearing that cost is mobilized by Karosamba, which is mobilizing the funds for upfront transportation cost of the waste through PBOs, producer, importers, and brand owners, and they have formed a consortium of it. And in return, these PBOs are actually getting the EPR certificates or end-of-life certificates, disposal certificates for fulfilling their EPR compliance or obligation. So this is a very interesting model where everyone is getting benefited. And then, this is how we can use EPR, integrate EPR in legacy waste management and try to get rid of the segregated combustible fraction. And it will become easier for the cities to manage their legacy waste in cost-effective manner. So this is a classic example of environmentally sound and economically viable disposal of segregated combustible fraction by the Indian cities. So I'll skip this one and I'll go to the way forward in recommendation. I think it's extremely important to develop standards for good quality segregated combustible fractions. So if you comply with this standard, basically, if you produce good quality segregated combustible material, it will, I don't think co-processing plants will have any issue accepting that. And promoting and adopting, EPR-led sustainable business models, as Prayagraj has done, is also one of the things that can be considered by other cities. R&D on treatment options. So yeah, we have many treatment options like, gasification or, different type of methods, but then upscaling has always been an issue. And I think we need some research and development in this domain as well. And promoting end-to-end disposal. So cities needs to be a little careful while selecting their contractor. The contractor should ensure that they are doing end-to-end disposal, starting from excavation, segregation, sorting, and then making sure that all the recovered fractions are appropriately disposed of. It should not happen that, you are hiring, as a city, you are hiring a contractor and they are just doing the treatment, excavating it, putting the material over there, and not, taking accountability of how these material needs to be disposed of. And phasing out disposal of combustible material, as I always say, the best way to deal with it. And I had a very interesting pyramid waste management hierarchy to show that, we know that this, reduction at the source is something that should be most preferred option. And recycling or disposal in landfill should be the least preferred option. So let us not create or let us not dispose of the legacy, the combustibles in the landfills or the organic waste in the landfills, because these will become a massive problem in the future and we have to again deal with it. And there is no circular economy possible because everything comes at a cost. If your waste reaches a landfill site, it becomes a waste. There's no way you can convert that into resource again. So yeah, so that's all from my side. And I would like to thank the three interns, that those who have worked with us, Surabhi, Chetan, and Muskan, for helping me in this study, and also the CAC team. So yeah, that's all from my side. Thank you. Over to you, Atin.
Much, Richa. It was very insightful. So without wasting any further time, let me bring in the first panelist for the day, Ashish Tiwari sir, who needs no introduction. He is the Secretary of the Department of Environment, Forest and Climate Change in the government of Uttar Pradesh. So, but before I invite Ashish sir to speak, I'd request my colleague, Dr. Tribhuvan, to please introduce him for all the participants. And then I have a small question for Tiwari sir before he speaks.
Yeah. Thank you, Atin. So, Mr. Ashish Tiwari sir is a senior member of the Indian Forest Services with over 25 years of experience. He has served as Secretary, Environment, Forest and Climate Change for the government of Uttar Pradesh. He has also held key policy and planning roles, including Member Secretary for the UP Pollution Control Board and State Climate Change Authority. His expertise span across climate change adaptation, biodiversity conservation, pollution control, and sustainable forest management, and has worked with global organizations like the World Bank, UNEP, and GIZ. Mr. Tiwari holds a degree from IIT Delhi and the Forest Research Institute and has received several awards, including the WWF Pata Baga Mitra Award for Tiger Conservation and commendation from the Governor of Uttar Pradesh for his contribution to the environmental conservation. Over to you, Atin.
Thank you, Tribhuvan. Sir, Richa has already spoken about the Prayagraj model. Definitely Dalmia Cement, Karo Sambhav and GIZ has played instrumental role. My question to you, like how the Department of Environment, Forest and Climate Change, the department that you head in the government of Uttar Pradesh, how did you conceive this idea and what were the potential challenges that you basically encountered during the journey? And what role the government played as to facilitate this the success of this project? And how do you think this model can be replicated in other parts of the country? Over to you, sir.
Thank you, Atin. Thank you so much, I think, for bringing in very important issue. Actually, this idea came into our mind because UP, is not a state, it's a country. It should have been 7th largest country in the world. So the scale of the problem in the state of Uttar Pradesh, Dr. Richa has shown some data on legacy waste and the solid waste which is generated across the country. I think UP takes the lion's share of it. And if you go around and if you see that really now the time has come, the urban local bodies and the government really is looking for a solution. There are, like if we go to our country scale, then we generate about 1.6 lakh ton per day of solid waste, and the legacy waste, because of non-functional our solid waste management facilities, the legacy waste as per CPCB data which CPCB produced before Honorable NGT in OA number 606 is 185 million tons of legacy waste across the country. And it is occupying about 15,000 acres of land. That is a Magua data. And UP, if we talk of UP, has got over 650 urban local bodies, 17 Nagar Nigams, 437 town councils, and 198 Nagar Palika Parishad. So the scale of the problem really drawn our attention as Environment Department, and we are always looked upon as we must provide some solution. And thanks to Swachh Bharat Mission and other financing which is coming in for solid waste management, that we are now able to at least put in place the installed capacity for waste management. But the challenge, I think it started from 2005 onwards, installation of facilities for waste management, but we have seen that most of the facilities have not worked, and the sites which were earlier actually the waste management facilities is now covered by the amounts of legacy waste. So that was, I think, the challenge which was thrown before us, and under Swachh Bharat Mission and many other schemes, the state has started biomining or bioremediating the legacy waste. Of course, the fresh waste is also a problem, but to get rid of somewhere, I tell you, somewhere the challenge was, if somebody has some Nagar Nigam has to install a new waste management facility, then UP is a kind of a highly urbanized state. They don't have land. So we suggested that if you are not finding land, the best land is you clear your legacy waste and get your the solid waste management facility over there. So these, I was just trying to mention some issues which really created a drive for finding out a solution. And when our urban development department and urban local bodies have started doing legacy waste biomining, bioremediation, then the problem came about this disposal of the non-recyclable plastic waste which is coming out from remediation of legacy waste. So when we took Prayagraj as a test case to test our you can say strategy, and the very recently the MOEFCC's EPR regulation was also put in place. So we saw that the challenge with smaller urban local bodies was the finances, and Dr. Richa has shown a wonderful map of India wherein the cement co-processing plants have been geotagged, and you can see UP being the largest state. It's a country and there is only one Ultratech cement co-processing plant in UP. So the challenge for disposal of RDF is the transportation cost. We understood in the beginning, and since Prayagraj had the legacy waste of Kumbh, Prayagraj is a city where is a transient population during Kumbh is very, very high. And apart from Kumbh also, there are many other bathing festivals. Prayagraj is a kind of city which will always have a very high degree of transient population, which will create a lot of waste and all. So that is why we took an example of Prayagraj city. And when we started, actually, the biggest problem was the quality of RDF. I think Saurabh ji is sitting over here. We started it with Dalmia cements, but now we are doing that with 7 cement plants which are located around 350-kilometer radius of Prayagraj. So the scale has really become very, very successful. And I'm so thankful to Saurabh Palasanaya ji that during our teething problems of RDF quality also, the Dalmia supported us. But now the Ultratech has also started, and so many cement kilns ranging from Satna to Katni, etc. They have also started taking RDF from Prayagraj, etc. So the quality of waste was a major challenge. And as Dr. Richa has rightly pointed out, we also felt that our team, when did a site visit and started researching that how this quality of waste can be improved, then I think then the issue came about the process modifications, and that also gave us an idea of developing SOP for this particular intervention. So now we with the GIZ we are developing SOP also. I will cite very few small process changes which have been made in Prayagraj to improve the calorific value and the quality and reduce the moisture of non-recycled plastic waste and RDF. Is like just a very small thing that the bigger, you can say the bigger size CND waste management was also mixed with it, so that we increase the length of the conveyor belt so that manually it can be picked before processing it further. Then we convinced the vendors to have very high quality and medium quality ballistic separators, and I am very happy to tell you, without any extra funding support from urban local bodies, the vendors understood the need and requirement, and they installed 4 ballistic separators. There are 4 vendors across, so everyone have got one ballistic separator, and high efficiency ballistic separator was also Durochem mod make was also installed, and so many modifications in the process, like proper demarcation of RDF processing area, because if you separate the CND waste and if it is lying there, then there is a chances of again remixing, and the CND waste which is separated is to be duly removed every day. So many, I am not going into detail of the process modification which we have made, and that has actually improved the quality of RDF. And not only Dalmia but other cement plants have also started taking our waste, and the role of the government is very, very important here. Like, it was not the urban local body only, but our department also intervened. The first thing which we did is we brought all the knowledge at the one board, like we were the facilitator, and then we had a dialogue with Dalmia Cement, Ultratech, Dala, Birla, Satna, and then Prism, Thomson, Riva, then JK Cement in Panna, and ACC Cement in Katni, Kamur. So we started dialogue with them, we facilitated dialogue with them. Of course, it was maybe out of track work for urban local body, but environment department, we understood that this is our responsibility to actually facilitate this process, and then we conceptualized this kind of MOU, and then we brought in the PIBOs, Karo Sambhav, and now many other brand owners have joined hand to actually the subsidize the transportation cost. So many challenges were actually mitigated, and the government has played such a role that to facilitate and take everyone, all stakeholder on one board and work for a common objectives, although they may be having different stakes in the process. So that was a difficult job, but I think is happened very well. And now for upscaling, we are developing one SOP on this model. And Lucknow has started remediating 18 lakhs metric ton of legacy waste, which is there near Shivri plant, and the 4,000, 5,000 metric ton RDF has also been taken away by the cement plants for co-processing. The quality has improved. The learnings of Prayagraj actually improved the bidding document for Lucknow waste management. And now we are now thinking of one step ahead, that wherever legacy waste management bidding is there, then the terms of reference would be that you have to have an MOU with a cement plant. So now the learning goes on and we are improving, and this is how we are going to upscale it. There is a good opportunity that there is a cement plant near Chittor of Ultratech, which can actually take RDF from Agra and NCR, UP, other nearby areas. So we are now working on a state level to tackle this problem. End of life by co-processing is also promoted and preferred under Basel Convention. So this is the best option available to us. And the state is also now thinking of having the RDF which is coming from the remediation of the fresh waste on the same lines, because if we are having a sorry, there was a disconnection in between. So I will conclude in 2 minutes. So the cement plants, if they are getting RDF, say for about when the legacy waste is remediated, say for a period of 2.5 years, but this kind of a partnership should go on. So that is why we are also thinking of putting our fresh waste to generate RDF and having good partnership with cement plants under the same EPR based framework, so that it can actually solve the problem in a long time frame. That was from learning from our side. We are coming out with an SOP. The draft is also under review, and I think we will put it in public domain, and it will definitely benefit other urban local bodies outside UP also to scale up this kind of successful intervention. And I thank Center for Science and Environment, Dr. Atin and Dr. Richa, to have put this success story in their compilation and research. And I think this will help taking it forward for other urban local bodies. Thank you very much.
Thank you so much, sir. This was really insightful, and I'm even more curious to learn more about this model, so that we can feed the learning into our capacity building, which basically what we do throughout the year. So going forward, whenever we interact with the urban local body officials, because most of the cities that we meet in our campus or otherwise, they are always challenged with dealing with the excavated fraction from the unscientific landfills. Thank you so much, sir. I know you are extremely occupied, but if you could stay with us, let me just bring in the other panelists, and there could be questions for you. So I'll come back whenever there are questions for you, sir.
Atinji, I will have to leave, because you can have questions mailed to me. I will respond definitely.
Sure, sir. I will do that. Yeah. Thank you, sir. Thank you so much. All right. So let me now bring in the second panelist for the day. Mr. Luke Redwell. I'm not sure, Luke, whether I pronounced it correctly. Please forgive me if I didn't. Luke is currently working as the business development manager in Harvest Waste in the Netherlands. But before I ask my question to Luke, I would request Dr. Tribhuvan to please introduce him briefly.
Thank you, Aten. So, Mr. Luke Ritwelt is a business development manager at Harvest Waste, as Aten told. He has also led business and project development as well as partner management since 2019 in the Harvest Waste. He previously worked for the Netherlands Ministry of Foreign Affairs, where he served as the primary liaison for Dutch business engaging with the Asian Development Bank, particularly in the Asian region. At Harvest Waste, Luke plays a pivotal role in collaborating with local governments and partners to implement sustainable waste-to-energy projects aimed at replacing landfills and open dumps. By utilizing high-efficiency waste-to-energy technology, these products helps reducing landfill, mitigate greenhouse gas emissions, generate baseload power, create local jobs, and foster the circular economy. Over to you, Mr.
Thank you, Tribhuvan. So, Luke, my question to you is very simple. Like, waste to energy, particularly for the non-recyclable plastics, are often criticized for their emissions, a concern that is globally raised by environmental organizations. So, how does your company ensure effective pollution control, especially in Europe, and how it can be done in the developing economies like India? Are there specific type of combustible that are more suited for waste-to-energy plants in such regions? Additionally, could you please elaborate on the impact of pollution control measure on the overall economic viability in the European context? Over to you, Luke.
Thank you very much, Dr. Aten and Dr. Risha for asking me. I had the privilege of sitting in a very good forum with Dr. Risha about 2 years ago in Delhi about SBM 2.0. And what we connected on was indeed the issue of emissions. We in Europe, and where we come from as our company in Amsterdam, we've been doing waste energy for over 100 years, and we've learned some very expensive lessons in how we deal with residual waste in the Netherlands. And why we went to waste management, and why actually the environmental standards and the emission standards for waste energy, which we employed in Amsterdam, became the standard for the European emission regulation, which is now worldwide the very much accepted emission standards for waste energy. And the problem lied in the fact that we did not treat our flue gases from waste to energy enough. And that led to serious issues in the Netherlands with pollution of grass, which the cow ate, which actually ended up in the milk, and which led to diseases among children. And in the Netherlands, therefore, by the end of only the 1980s, we really started working on cleaner emissions from waste energy. And that's both waste energy plants and cement plants. Because if you don't do that, we're diverting the problem elsewhere, right? The solution to pollution is not dilution, but you really have to clean it up. That is what we learned in the Netherlands. So extensive pollution control is something that we as a company advocate, and which also the financiers would like to see. If you do not follow your international standards, and that's the European regulation 2010/75 at least, an IFC will not invest in a project for waste energy or similar. So that is the key. So that experience from the Netherlands has led us to only implementing projects following at least the 2010 standards, but our plant in Amsterdam, even though it's already in operation for 15 years, already still achieves the latest European standard, which is the BREF standards, which are even stricter in terms of regulation. And why is it interesting to implement this in India as well? For every so we've calculated based on the cost of the emissions, and especially the heavy metals, the volatile organic compounds, the POPs, etc. And we calculated that we can save the society between $135 and $200 per ton of waste that doesn't go to landfill, but is rather treated in our facilities following those standards, which is huge. And the investment is relatively small. Going from the 2010 European standards to the 2019 standards, in our case, would cost you only $5 per ton. Well, and the savings is more than $60 on a societal scale, which is why we would strongly advocate for in any country that wants to do waste energy, and whether you do it via the measures via cement plants or via waste energy plants, to really start following stricter standards. And India has a decent set of standards already in SBM from 2016, but it can be better, because then you can make even more impact. Of course, the challenge lies in financing this. And this is where our technology comes in. We've developed in Amsterdam waste energy technology under high efficiency, which generates 30 to 40% more electricity per ton of waste. We can do that by specific boiler design, for which we're actually working with some Indian parties to have it manufactured in India for cost reasons, but also quality reasons now, because we hardly produce these boilers anymore in Europe. Making sure that we can produce more electricity, which makes the business case financeable and feasible to implement waste energy at the same cost as currently landfilling, with the same standards. And that makes it a win-win situation for everyone. A win-win situation for society, because in the end, first and foremost, waste energy plants are environmental project for solving a waste problem. That has to be the key underlying factor that we also learned in Europe. You cannot compete with wind and solar in terms of cost per kilowatt, but you can compete with these in terms of impact. And that's why we strongly believe that high environmental standards, high emission standards for waste energy also in India can be done, should be done, and should be strictly monitored. In the Netherlands, for a long time, we've had biomonitoring with our new waste energy plants done by the Wageningen University. TU Delft, Dr. Risha is also involved in that, to monitor the impact of these stronger emission standards. And for as long as they've been doing that, waste energy plants in Europe, which are located in the cities, do not show any exposure, any higher exposure than the normal ambient air towards the problems that we saw earlier. So it can be done. It just requires, similar to what you in your very well-written paper suggested, operating procedures, and it requires the government to really enforce it. And because that is, I think, a challenge in India. There are some waste energy plants, but I've been speaking to many people while I visited India, and I hear even some of the current operators say, I cannot, with the current way that we are financed, make a plant that is environmentally sound. And that worries me. That is really worrying, because then, we're not solving a problem. So we need to work together. We believe with our technology, we can bring the cost down. It does require a bit of scale, and it would also really require the government to set more stricter standards, but also be willing to pay for it, because the environmental gain that we can all make as a society of using waste energy to take care of the residual fraction, and whether that comes from the RDF of legacy waste, but also the residual fraction out of previously mixed waste, that should be treated according to the best possible standards. And it has that comes at a cost, but it has a way bigger impact than the cost. For $5 per ton, the benefits outweigh the cost by a lot. And just to put it in context, in the Netherlands, we have 12 functioning waste energy plants. We started with this in Amsterdam already a long time ago, but most of our waste energy plants were built in the 90s and the early 2000s. At the end, we've managed in the Netherlands by a combination of capping our landfills. So we did not do landfill remediation in the Netherlands, but capping landfills that came with a landfill tax. So I completely agree with Dr. Risha's last statement that in order to reduce the volume of combustible waste going to landfill, we should rethink whatever happens before that. But until that time, landfill taxes have been implemented in the Netherlands. So combustible materials are not allowed to go to landfill. So that's landfill forbidding landfilling, landfill taxes, which creates diversion. Of course, you need waste energy, pay for the waste energy, and then implement these strict standards. And that allowed us to reduce the emissions from waste in the Netherlands, and that's a combination of methane and all the other volatile compounds, by more than 90% in the 20 years. And that is by far the biggest environmental gain that we've had in the Netherlands on a CO2 equivalent scale. And that has not been achieved by our agrarian sector, but mostly solely by waste, better waste management. So, and we believe that waste energy plants with strict standards play a vital role in this, but it comes at a slight cost, but it far outweighs the benefits that we reap from it as a society. Thank you. Happy to take any questions after this.
Thank you. Thank you so much, Luke. It was really, really very insightful. Let me bring in the other panelists before I come back with a question from the participants. Let me now quickly bring in the next panelist, Swachh Bharat Mission. Swachh sir doesn't need any introduction as far as the Indian cement industry is concerned. But before I invite Swachh sir and ask my question, I would request again Dr. Tribhuvan to please introduce him for the participants.
Yeah. Thank you, Atin. Mr. Swachh Bharat, he is a chartered accountant with over 25 years of experience, is joint president strategic sourcing at Shree Cement Limited. He has pioneered sustainable initiatives such as using green fuels, electric and LNG trucks, and digital procurement in the cement industries. His effort is driving sustainability and operational efficiency, includes innovations in the fly ash transport and refuse-derived fuel logistics. Mr. Saurabh is actively involved with prominent organizations like FICCI, CMA, and WEF, and has received multiple awards, including the Green Hero Award and CPO of the year 2022 for his contribution to sustainability and procurement transformation. Over to you, Atin.
Thank you. Thank you, Dr. Tribhuvan. So, Saurabh sir, I mean, there's no better person than you to answer question when it comes to co-processing of plastics and similar combustible waste. So what practical challenges do the cement co-processing units face these days when disposing of the legacy waste derived from the process of biomining compared to the fresh waste or fresh waste which are combustible in nature? So how do you think that the combustible waste from the landfill mining differ, and what adaptation are necessary for their management, and how the current EPR regime models for legacy combustibles can be a win-win condition for all the stakeholders involved? Over to you, sir.
Thank you, Atin, and congratulations, Richa, once again. I think that I know the days when you were on the job to prepare to go to these dump sites, and you were sharing your experiences at that time also. But definitely a lot has been done in the last 3-4 years by the various stakeholders who are engaged in dump remediations and legacy waste remediation. So first of all, I will start from the last question. Probably so most important is that the EPR norms presently, which says that 70% of the EPR liability should be taken care of through recycling and 30% through end of life. I think that is where I would say that we should review again, because in today's scenario, the recycling industries have not been multiplied in the numbers such that the liabilities of PABOs is taken care of to the extent of 70% by recyclers. So end of life is where, which is important for every one of us as a citizen also, and as a stakeholders also, or waste generators also, that end of life should occupy a major part for liability to cover up the liabilities of EPR, and we may fix up these percentages based on the say volume of the sector. So how many recycling industries are there? I think we'll not end up saying more than say 10,000 tons of recycling is done today. Second important point is that in RDF, when we say that how much plastic content is there, and EPR also says the same thing, that maybe that 20% to 30% of liability can be set off through RDF consumption. So I would say that RDF itself contains whatever RDF is being transported by the say RDF, you can say biominers or the consumers or the transporters, that contains almost say out of one ton or 100 tons, 30 tons is inert waste. And maybe when we talk about the say energy recovery content, it may be ranging between 15 to 25%. So unless through EPR also, initially till we are able to manufacture right quality of RDF, which is grade 1 RDF or grade 2 RDF, I mean the EPR should be allowed to the extent of the RDF being consumed, which is presently not so, and that will help in faster say clearance of landfills or dump sites. Then third is, a lot of, you will say that earlier on, maybe 5 years before or 7 years before, we could see a lot of plastic bottles, lot of say plastics, even plastic packaging material were, on the roadsides. But today it is not there. Similarly, what we need to develop is the habit of source segregation into dry and waste, which will improve the content or quality of RDF, SCF also and RDF also. So how this, habit of source segregation, that is dry and waste, can be made mandatory or can be say convinced, say general public or maybe the institutions or hospitals or government offices, how we can inculcate that habit that dry and wet waste is segregated or stored separately. So that will improve the quality also. And lastly, say minimum quality standards of RDF, like for cement, BIS is setting up those standards. So similarly, quality standards for RDF needs to be announced, to be tabulated, and to be made mandatory. That will also help Government of India also, state governments also, Pollution Control Board also, and maybe the cement industries also, which can get the right material, and legacy dumps can be cleared on fast track basis. And when we say quality standards, that will definitely we know what are the equipments required to bring that quality. Like Richa also showed the air density separators importance, and similarly the right quality of ballistic separators, trommels, and so on. There are a number of equipments today which are being used by many of the recyclers also, and maybe pre-processing units also, and they know that what type of equipments are to be installed. So these four things are very important to bring up the right quality of RDF. Now coming back to one of the questions that says why fresh waste and not legacy waste. Many of the points have been already raised, but I'll say that the ash content and chloride contents is much higher in legacy dumps because maybe the combustible fraction is being segregated not only at the source. These days, when the material moves out of your colony or your institution, it is segregated in terms of plastics and non-plastics, or maybe PET bottles and other materials. And then when it moves to the dump sites, again the plastic content is taken out of those dump sites. So if we say that in fresh waste, the CV is ranges between 2800 to 3500. After taking hydrogen out of it or the moisture out of it, then you will find that it is not more than 2000 to 2400 calorific value in dump waste or legacy waste. And that is the major difference. Secondly, because of the higher content of ash or say sands or inert, the ash content is too high. So it tantamounts to around 33 to 35% ash content in RDF at dump sites, while in fresh waste, it may range from say 18 to 25%. So that is only the biggest say hurdle in in co-processing the RDF from dump sites or legacy dumps. Another important point, which you highlighted rightly, is that how the say transportation cost can be reduced. So again, I'll say that if the sand is inerts are segregated properly, and maybe the content is reduced from 30 to as low as possible, then the transportation cost will also be reduced, and the net cost to the maybe to the biominers or to others will fall down drastically. So this is from my side, and thanks for giving me the opportunity to speak.
Thank you so much. Thank you so much, sir. It was truly insightful, and the challenge though continues. And like you mentioned very correctly, even in fact, I was looking at a couple of questions from the participants, that what about the places where they don't have a cement industry nearby? So the cost of transportation goes even higher. And in some cases, like Richard spoke about Leh, so Leh is transporting their segregated combustible fraction to almost 300 to 400 kilometers away. So per truck, the cost is kind of insanely high. I would request you to stay back with us, sir. I'll come back with questions for you as soon as we are done with other panel.
Minutes.
I'm sorry, sir, please come again.
I'll join back in 15 minutes.
Sure, sir. Go ahead, sir. Sure. Yeah. Thank you. So let me bring in the next panelist, Mr. Palas Kumar Shah. I fondly call him Palasda because we both are from Bengal. So, but before I invite Palasda to speak, I'd request Dr. Tribhuvan to briefly introduce him. He's joining us from Oslo, Norway.
Yeah, thank you, Aten. So, Mr. Palas Shah is a waste management expert based in Oslo, Norway. With over 18 years of experience since 2014, he has worked at SCF, leading international and bilateral waste management projects funded by the Norwegian Ministry of Foreign Affairs and NORAD. His expertise span waste inventories, feasibility studies, hazardous waste planning, and recovery demonstration pilots. Before SCF, Mr. Palas spent over 8 years at Geocycle in key roles across supply chain management, business development, and operations. He has authored several articles and reports, trained professionals globally, and regularly speaks at international conferences on sustainable waste management. Mr. Palas is known for his collaborative approach, innovative strategies, and fostering new perspective in environmental sustainability. Over to you, Mr. Arden.
Thank you, Tribhuvan. So, Palasda, you have experience of working both in European region. In fact, you are based out of Norway, and you have also experience of working in your own country, India. So, can you just throw some light on the thermal substitution rate in Europe and other parts of the global north compared to India? And what steps, according to you, can be taken to improve the thermal substitution rate in India? And what measures should be implemented to achieve this? Over to you, Palasda.
Thank you so much, Atinda, for inviting me to this report release. And I must congratulate Richa. I've just gone through this report yesterday, and it has come out very well. Especially, the list of the waste to energy and the list of cement plants which you have extracted from the EPR was very useful for us because we are not privy to those kinds of information. So that was very valuable, at least for our work. So thank you for that. I don't know if can you see my screen in properly? Is it okay?
Yeah, yes, Palasda. Go ahead.
Yeah, okay. So I'll just go briefly through a few slides. We basically say what are the three major energy intensive industries, and that is cement, steel, and power. And together, if you see India's CO2 emissions, if we consider it close to 3 billion tons, so these three sectors actually contributed to 55%. If you see in terms of co-processing is applicable to all these three industries because they use more than 800 million tons of coal every year, and replacing parts of this coal is with waste is what we call a win-win co-processing solution. Steel industry in India at least has no or very limited experience in co-processing, and the power industry has, of course, when we were working with CPCB, we have been working with them since 2010, and we have conducted some limited pilots in captive power plants, but it could not be scaled up. But of course, you have similar waste to energy plants. It's the same concept. And in cement, Indian cement industry is the second largest in the world, one of the most energy efficient because these plants, I think almost 60-70% of these plants were installed in last 20-30 years, so it has the best available techniques, and it's known for utilizing humongous amounts of fly ash and slag as clinker substitutes, and therefore you will see some of the Indian cement companies and plants are best in terms of carbon footprint in the world. If you see the waste management hierarchy, you may know this, but if you see co-processing specifically, it falls in the realm of material recycling because you're recycling some of the oxides that you need in clinker and cement production, but it also aids in energy recovery. But for very few selected waste, like if we are talking about destruction of pesticides or persistent organic pollutants or CFC gases, etc., so then we use cement plant as a disposal option. To answer the question, if you see the TSR achieved, and this data have taken from the Global Cement and Concrete Association, they are the largest and I think represent almost 70% of the cement production in the world. So if you see the global TSR in a sense is approximately 23% from biomass and from alternative fuels. And if you see the mix of alternative fuels, the biggest fraction is coming from the RDF and plastics in the cement plants. Yeah, I know there are few colleagues here from Netherlands, and I have somehow missed them out. But Netherlands, I must say, is one of the leading countries in the world in terms of TSR substitution. So you can see, of course, there are few European plants which are leading the TSR development journey. If you look at EU 27 countries on an average achieves 50% TSR, in a way to say that half of the heat required for cement production is substituted by waste, and that's how you should read this number. When it comes to India, when we started this project almost 14 years back, there were only 2 or 3 cement companies which were doing co-processing, and the TSR was 0.5. This 5% is actually industry wide. So because India has, of course, 350 million tons of production every year, so this number looks very small, but if you see in absolute scale, these numbers must be very, very high, like in terms of quantity of waste co-processed. So we say that it's little over 5% industry wide, but you see companies, I'll show some slides, companies achieving more than 10%, 15%, and we have plants which have achieved up to 40-45%. If you see the Asian cement industry in general, it's very less, it's moderate 3%. If you consider the entire Asian cement industry. Norway, we have only 2 cement plants. One's in the north is called the most northerly plant in the world, and we have one in the south. And these 2 plants have been substituting more than 75% of their coal requirement by wastes. And Norway has never built an incinerator for organic hazardous waste. So they have always used cement plants for destruction of the organic hazardous waste. Yeah. If you see the waste co-processing status in India, second largest, we have more than 500 million tons. I think this number is reaching almost 600 million tons now of installed capacity. Little less capacity utilization, approximately 65 to 70%. Uses more than 40 million tons of coal, and we have not included the coal used in the captive power plants. If you add that, it will add around 20-30 million tons more. TSR currently at 5 to 6% for the entire industry, and few plants are operating at more than 30%. Here, these are figures from 22, 23, so little old, but these figures might have grown a little bit more than what it is. So Dalmia was leading the pack with 13% TSR development. Cement industry has made millions of dollars of investment with their own volition, and because they saw a business case in investing. And I would say all the progressive cement plants and companies that you see on the left side have invested in tens of millions of dollars in pre-processing and co-processing facilities. India is a very unique country. We have conducted more than 80 demonstration trials. I don't know anywhere in the world if so many trials have been conducted, but this was primarily because when there was no, I would say, favorable guidelines, the cement industry were mandated to do trial for each and every new waste stream that was used in the cement plants. And that's why you see more than 80 demonstration trials which have been conducted. But now the regulations broadly support co-processing, and we have several separate guidelines and specific SOPs which addresses specific waste streams going to co-processing. And it's also considered as one of the important levers for GHG emission reduction, in addition to energy efficiency, clinker substitution, carbon capture and storage. Like, these are the various levers of GHG emission reduction in the cement industry. Co-processing is also considered one of the important levers for GHG. Of course, some of you might know that, I'm so sorry. CII had come out with a roadmap, industry roadmap for achieving 25% by 2025. That was a little bit, I would say, ambitious target, but we are getting there. And if you saw the waste stream that they considered, almost 60% of that was municipal solid waste, or RDF, specifically coming from dump sites and fresh wastes. I don't need to go into that. I think Richa has already talked about these figures. But plastic in SCF, 30 to 50% is also something that we have observed in India. In few countries like Thailand, which use a lot of plastic, for example, and if you go to a dump site, you can see up to 80 to 90% plastic. So it's only plastic in the dump site. So it's very, very high there. And we just did some calculation, and more than 5 billion tons of plastic waste is actually dumped in the world's environment, which will eventually leach as microplastic and end up in oceans. We have been doing a project, and our project, just like the CSE project, is also part of the India-Norway Marine Pollution Initiative, but ours is a regional project in several countries in Asia. And we are basically targeting only non-recyclable plastic waste and conducting pilot demonstration in local cement plants to basically explore the feasibility and limitations of co-processing. To increase the local treatment capacity, substitute coal, as well as reduce microplastic release. I don't know how to minimize this. I'm sorry, maybe this one might be coming in the screen, or I don't know. We had 5 countries initially, but we have several more countries which have joined the project now. We have tested different kinds of non-recyclable plastic waste from 4 important sources: dump sites, industries, municipalities, and floating plastics in water bodies. And you can see some of the locations of the pilots that we have conducted. And so far, we have conducted 17 pilots in 5 countries: China, India, Vietnam, Thailand, and Philippines. And it reveals that that would actually lead to more than 800,000 tons of waste containing NRPW can be co-processed, which means it will not be ending up in water bodies, and it can help in saving 450,000 tons of coal. And the dioxins, for example, which is one of the emissions that everyone talks about, like if you put plastics in cement kilns, it will lead to dioxin emissions. We have never seen increased dioxin. And in cement plants, it's one of the most stringent, also in the waste to energy plant, which is 0.1 nanogram toxicity equivalent per normal meter cube. If you see some of the drivers, we would say, of course, we need more investment. This WBCSD, and it's not IEA, sorry, it's IFC of World Bank. They had made a carbon roadmap, which is now, of course, more than 10 years old. But they had estimated at that time that for achieving 25% TSR, or quarter of the coal replaced in cement industry, would require 5.5 to 6 billion dollars of investment. So we still have a long way to go there. Of course, you need supply certainty if you want to make big investments. And there, I think we need, which has also been discussed today, we need bipartite, tripartite, multipartite agreements for ensuring that large volume of supplies are received at the cement plants or waste to energy plants. Transport is, of course, one of the limitations, and we have done some calculations, and it's basically you can save more than 50% in transport costs if you actually locate the waste treatment plant close to the waste generation and transport pre-processed waste to the cement plants instead of sending raw MSW or SCF containing inerts and moistures. So you're basically paying for transporting inerts and moistures in that sense. Health, safety, and environment, this is very important, because if you put up a facility and one fire and the whole company management, it will basically make them very diffident in making investments. So very strong and strict protocols needs to be installed when it comes to health, safety, environment, firefighting, etc. I have seen several plants which are doing good amounts of RDF, for example, but not too much focus on this. Like I did not see, for example, retention ponds and adequate fire pumping systems, etc. But this is very, very important. Because as they say that there will be accident in a waste treatment facility. It's how you actually manage it, and as soon as possible is what will distinguish you. In Europe, as you know, or maybe Luke and others would know a little better than me in this, but as far as I know, there is a reduction target to landfill, and they want to reduce the landfill to 10% by 2030. Already the developed countries have reached those targets, but this we are talking about overall European Union. And this, of course, also boosts waste to energy and co-processing in a sense. And in India, we say that there has to be some kind of a level playing field when it comes to landfilling and waste to energy, because, of course, waste to energy is quite subsidized. And it's been one of the points which cement industry always say that at least they should get some kind of reprieve when they're getting imported equipments and all in terms of subsidies. Polluter pays principle is very important, and we need to actually develop some innovative, cost recovery business models because this reduces the financial burden overall. If the polluter doesn't pay, then it means that someone else is paying on their behalf, and then there is always friction. So sometimes it's the municipality, sometimes it's the waste processors, sometimes it's the cement plant. So I think it's the polluter who has to pay to reduce the overall financial burden of the waste management. EPR, 80 cement plants, and I've taken this figure from Richa's reports, which is very good. We know that EPR has been rolled out really successfully or fairly successfully. However, a robust oversight, because as far as I know, the plastic credit trading has not yet started, but we need a little bit more robust oversight when it comes to, proper accounting of quantities co-processed, how much plastic in the waste that has been co-processed, etc., etc. Carbon pricing, this will be a huge fillip, because as you know, cement industry in India also contribute to almost 7-8% of the country's GHG emission. Globally, also cement sector contributes to 6 to 8%. So the moment there's a good price of carbon comes, like in EU ETS, last I saw it was trading at 80, 90, and they are trying to reach this figure of 100 euros per ton. So it's almost equal to 1 ton of cement sold in India, for example. So you can see how it can actually play an important role in incentivizing co-processing development. I think those are the points from my side. Thank you. I'll be happy to take questions.
So much, Palasda. Really, really insightful. And we also understood the diversity between the Indian model versus the model that we have in the European region. Let me quickly bring in the next speaker from the panel, Mr. Varun Buralkar. So Varun is joining us from London. He's traveling, and we caught him in the middle of his travel. But before I invite Varun and ask my question, I'd request again Dr. Tribhuvan to please introduce him.
Yeah, thank you, Adan. Mr. Varun is a waste management professional with 14 years of experience in wastewater and solid waste management. He holds a mechanical engineering degree from Pune University and master's in environmental management and technology from England. Currently, he is the vice president of the strategic business group at Blue Planet Environmental Solution Limited, where he leads the alternative fuel and raw material business. Mr. Varun has held key roles in business development, operations, and advocacy at companies like SMS Infrastructure, Ramki Enviro Engineers, and Wholesome Cements, focusing on recycling and resource recovery. As a former head of the commercial strategy at Geocycle, he played a vital role in co-processing alternative fuel and raw material, pioneering in circular economy model for the spent pot lining management in the project at Hindalco in collaboration with ACC Limited. Over to you, Atin.
Thank you, Tribhuvan. So, Varun, thank you so much. I know that you have back-to-back meeting schedule and we somehow managed to escape and share your views. So my quick question to you is that, cement plants have always raised concern about the quality of legacy combustible used for co-processing. So from the industry's perspective, what can be done to improve the quality of SCF, and how can Indian cities better address these quality issues during the process of biomining or landfill mining operations? Over to you, Varun. Thank you so much.
Yeah. Thank you so much, Atin and the team at CSE, and they've done quite a extensive job as far as the SCF utilization report is concerned. Before I start, is my screen fully visible?
It's visible. If you could go just full screen mode, that will be great.
Okay. So before I do that, one critical area for any waste management policy or any waste management initiative in any country to be effective, the enforcement of the law is essential. The policy shapes the waste management business. Compliance and enforcement of the rules drives compliance. And when we take this as a rule to the biomining situation in India, I think there are enough tools available as far as the legal aspects are concerned. You have the biomining or legacy MSW biomining guidelines issued by the Central Pollution Control Board in 2019. The image in front of you is a depiction of the process flow that we need to follow. And one key area is that every aggregate that is being generated should be in line with the standards and the quality that has been mentioned. And every biomining company which is working should be following this as sacrosanct. To answer your question, Atin, what should be done in the cities better? I think we need a better concession agreements. We need better tender documentation. We need very clear, very clear terms and conditions mentioned exactly what is it that needs to be achieved when we are doing legacy waste biomining. We've now done more than 25 projects in the country. And what we find is that there is a lot of competition. Of course, there should be competition. There is no denying that. But the level playing field as far as the processing of the waste and how the aggregates are being generated, how the aggregates are being processed, and what is the segregation efficiency of these aggregates from the MSW. That is the most key part. Today, the pollution is in one place, which is the dump site itself. We do not need a situation where that waste is simply getting distributed into different parts of the closed geography that the dump site is in. So we need a good enforcement on the compliance side and enforcement of the guidelines, and we need to have good monitoring mechanism for the biomining projects. When we start putting a reasonable cost of compliance to the biomining projects, that is when we will start getting good quality aggregates. What I mean by that, I will share in the next couple of slides. But before I go to that, I would like to reiterate the point that what we find many a times is that there is a lot of doubts and a lot of submissions made to the biomining companies that the price is too high or the cost is too high, but the cost or the processing cost is not being measured, or it is not being calculated in terms of what is the level of compliance that we are going to achieve. In all the conversations that I'm listening to, the health of the biomining companies is essential. If the biomining companies are not doing their job, we are never going to get the right quality of aggregates that we envisage. Whether it is RDF, whether it is stones, whether it is soil, whether it is the soil nourisher, whichever way we look at it. So it is essential that the guidelines of CPCB are properly enforced. All the aggregates find the right and scientific way of disposal. RDF, of course, can go to waste to energy and co-processing. Just to sort of take that point forward, we, in the last 3 years, if you can see the data that we have, we've now co-processed more than 1.2 million tons or enabled 12 lakh tons of RDF in the cement industry, and part of it has also gone to waste to energy industry. One of the key reasons that we've been able to achieve these numbers is because we've got a very robust processing that we have at our sites. We are following the guidelines in toto. The compliance is at the heart of it. It is not just about producing good quality RDF or just for producing good quality stones or soil or whatever that may be. But what we've seen is that we need to have a very good process in place. It's not just about a bunch of trommels or a power screen and you're just getting three types of aggregates and then we are satisfied. No, there is still microplastics in our soil. We need to bring it down to less than 5%. That's what we've been able to achieve in the soil that we produce. 80% of the legacy waste sites are full of inert, which will be stones, soil. You've got organic waste, which has been decomposed over the years, and it is now down to soil itself. So what we are submitting continuously to the government, to various policymakers and regulators, is that we need a better mechanism to monitor the biomining projects. We need to have a far more standardized way of tendering the biomining projects so that you have uniformity across the board. It's not just about a few states, or the problem eventually is that we need to protect the environment, and that's where I think there is a lot of debate. We find ourselves in the middle of it at times, but not achieving the ultimate goal of the compliance. I think then we are not doing the right thing, or we are not serving the environment or the country in that manner. So just to give you a few pieces of information, this is some of our projects. When I say that we are following the guidelines, we are trying to do the best what we have in terms of the technology. We've developed our own technology. We manufacture all our equipments. We have to make sure that waste has to be pre-stabilized. It has to be given the time for decomposition. That helps in better segregation. That helps in better segregation efficiency of the machines, and automatically it will generate better quality of aggregates and RDF in this case, since we are talking about RDF here today. This is a project in Vijayawada. 45 acres of land is already cleaned up. You can see at the back end of the photograph, there was incomplete housing projects which have now been completed. The area has also been habitated now. And this is the impact that we can make. But to do that, we need to start looking at following the process very diligently. Again, I'm so sorry. This is a dump which was right next to the river Kaveri in the town of Erode in Tamil Nadu. Drinking water source, E. coli levels far higher than the WHO standards. But now the site is clean, and then now the natural remediation of the water body will start. This is in Gujarat, in Baroda. This is right next to the river Vishwamitri, which habitates the endangered and very specific to that ecosystem, the gharials, or alligators, which are very specific to that ecosystem. And now with leachate having stopped from the dump site, that ecosystem will be far better protected. Again, far better quality-based tendering process, looked at compliance more diligently than only the commercial aspects, put environment protection at the heart of it, and that's what we've achieved there. This is another project in Nagpur. About 53 acres of land has been recovered and handed back to the municipal corporation, where they are now setting up a new MSW, fresh MSW processing project, a construction demolition waste project, and for some other utilization for the urban local body. Again, a lot of back and forth, but the right approach was taken, not just by the concessionaire, which is us, but also I have to admit that the municipality did not, take a shorter route to achieve the right result. This is in Kerala, in Kollam, a lovely, beautiful place. You can see the images are very, very drastic. And you had an eyesore on the left, but now it's a much cleaner place. Again, this land will be utilized by the municipality for their use. Coming to the RDF part, I'll just break it down into what needs to be done, how it needs to be done, and who has to do it. First of all, what needs to be done is that we need to institutionalize RDF. How do we do it? We need a very clear, simple RDF testing protocol, which has to be agreed by the waste management companies as well as the cement companies. We will look at cement companies to sort of handhold us because they are in the energy business. We are not. We are looking at them to support us. They need to share their learnings. And we need to come up with parameters which are very clearly defined, not just between the agreements between cement companies and biomining companies, but also these could be part of the tender agreements, tender documents, so that the biomining companies who are bidding can establish proper infrastructure that all can be accounted for in their process, so that you have a level playing field when you are bidding for such projects. So there we need a sort of a working group. That is my appeal. We've also made certain representations at the MOHUA level and even at the Ministry of Environment and Forests and Climate Change, that we need a working group where it will be waste management companies and cement companies come together. There is Cement Manufacturers Association. There are committees from cement side at the CII forum, even FICCI. We need a working group to come together and finalize, because a lot of things could be unrealistic. Today, both sides are going to the government and going with their wish list rather than coming up with real solutions. Nagpur produces only 12% RDF. out of the all the MSW that is getting processed. Noida produces 27%, Chennai produces 21%, Baroda produces 18%, Guwahati today is producing close to 38%. So how do you figure all of this? That's why it is essential that we need to come together rather than publishing our wish list. We need to talk to the government very openly and come out with a very clear point. Long-term commitments, establish pre-processing infrastructure either at the RDF site, MSW site, or at the cement site. It's one and the same, but you need long-term commitments from both sides so that you have proper offtake of RDF. The economics, of course, without economics, this is not going to work until unless we do not invest in waste management through infrastructure. We are not going to achieve our ultimate goal. So we have to have good economics. We need good infrastructure. You need good equipments, efficient equipments, large scale outputs, so that you can start delivering the right kind of product. And that's how it will become a business. And that is how you will be eventually be able to support environment protection. There are n number of guidelines. Yes, there is the famous Mohua report, but some of the parameters given in it are very sometimes very difficult to achieve. They cannot be achieved all year long. It needs to consider monsoon periods. It needs to do a lot of things. So it is a very good start, but there needs to be a bit of a discussion amongst the stakeholders. And somehow I feel that waste management companies and cement companies are working in their own little silos. I think they need to come together on RDF management. Why not have a RDF dashboard? How much waste is getting produced, so that we can know where is the RDF going. Still, traceability and transparency is the key to compliance. We give a lot of impetus to it. We have a very sophisticated IT-enabled ERP system where every single kg of RDF, every single kg of soil, glass, everything is tracked, and we know where it has been utilized. Again, inert soils, we are talking about very similar ways of working, and whether there will be any TSR percentage from RDF, which will get mandated, not mandated. I think instead of mandating, we should be talking about incentivizing. Landfill tax, for example. I'm right now here in the UK. There was a beautiful graph which was shown to me the other day by someone, how the landfill tax has increased in the country and how the waste going to the landfill has declined. It's a very nice graph. I'll try to incorporate it in this presentation and share it with the team. One final thing is that there has been a bit of discussion on EPR. I'm currently EPR in its current shape and form. Yes, it's a good start again, but the waste generators, the MSW processors have actually got no role in it. Today, it's all credits based. It's an online system. There is not a lot of waste which should really be moving from, plastic should be moving from the source to the end of life solution provider or recyclers. So we need to find another step, upgrade it a little bit. Do not sit on the existing system and pat our backs. I think there is continuous scope for improvement. And that is where we can bring about a bit of a change. And that should not be at the core of it. EPR is part of it, but the real big picture will only get completed when we have the rules, SWM rules, legacy waste guidelines, working together, getting enforced, and then the EPR also adds a very nice, it adds a lot of value to it. And that's when we start becoming a good circular economy. So first, compliance, sustainability, and the circular economy. So this is something that I wanted to share with all of you. I hope I was clear. I was able to send across the message. I have to say this, internet connections in India are far better.
Thank you so much, Varun. It was absolutely very insightful. Let me now bring in the last panelist for the day, Rene Rosendahl. So thank you so much, Rene, and my apologies to kind of make you wait because I just wanted to ensure a balance between the Indian speakers and the international speakers in intervals. So thank you so much for the wait. But before I bring in Rene, let me again request Dr. Tribhuvan to quickly introduce Rene to the participants.
Thank you, Adan. Mr. Rene Rosendahl holds an MSc in Technological and Social Economic Planning and Geography from Roskilde University. With over 20 years of experience in the waste and environmental industry, Mr. Rene is a recognized expert in landfill mining and waste management. He currently serves as the vice chair of the ISWA working group on landfills. Mr. Rene is also a partner at Danish Waste Solution, a consulting firm, and works as a senior project manager at the AV Miljo landfill in Copenhagen, where he continues to advance innovative waste management and landfill remediation solutions. Over to you, Atin.
Thank you so much, Tribhuvan. So Rene, I have a very precise question for you. You know, the disposal or thermal treatment of combustibles derived from the landfill mining is a significant concern all across the world. So how is this issue managed within Europe or with reference to your own country? And what insights can you share about the strategies used to handle these challenges in landfill mining operations? Over to you, Rene.
Thank you. Yes, that's correct. We have more or less it's the same solutions when we sort our waste in India and in Europe. We get the same outcome. You can say more or less we get the fine fraction, we get the RDF or the RCF or what you or SCF what you call it. And then we have some recyclables and things on. But the problem is that when you compare the landfill mining discussions and compare it to India compared to Europe, there are some major differences between the different countries. For instance, I live in northern part of Europe. We have a very well developed waste management systems. We have source separation 10 fractions at our households. We had the first environmental law from 1972. We had the first landfill regulation in 1982. Standards for building landfills, so we actually don't have the same problems as you have in India. And when it comes to the RDF fraction, Europe is actually very well known for having waste to energy plants and cement kilns. So we have no problems with getting rid of that specific fraction more or less, because we also know that from your learnings that we can actually take out the recyclables, the plastics, the textiles, but we also know that it's the quality of the materials are actually not recyclables. So at the end, we cannot sell it, we cannot process it because the quality is poor. So therefore, we often have to put it into incineration plants, and it's actually gone. If it contains a little bit of inerts or a little bit of metals, we can take it from the source, the slag separation, and the slag separation in Europe is actually also very good, so it's actually not a problem with the RDF in Europe. The problem in Europe is more or less the fines, which you don't have any problems with. You probably have problems with it, but the problems in Europe are more or less the fines, because the fines are regulated by different standards. We need to analyze the material before we can recycle it. So we have different standards that we need to follow, and often the fines are actually the actual problem in a bigger part of Europe, not the recyclables, not the RDF. We can get rid of that, more or less. Yeah. At least that was we experienced for the last 10 years.
Atin, you are on mute.
You're muted.
So sorry. Rene, thank you so much. I mean, you had prepared a presentation, so is there anything that you would like to refer back to the slides? Can I just put them on? Yeah, okay.
Yeah.
Okay.
Because, yeah, and also Luke, he told you a little bit about the waste to energy standards also, so I'm not going to discuss that with you. The next one. So what I actually did was I looked at the report, very well written. It actually gave me a good insight in what are you dealing with in India, and congratulations, because 10 years ago, landfill mining in India was probably not an issue. So you have come really far so far. So congratulations. Next one. So I looked into some of the main findings, and I'm going to discuss some of the similarities and the differences between Europe and India. Next one. So, as we have been discussed, I've been attending a lot of landfill mining or biomining discussions with India for many years, and as you can see, that landfill mining or biomining is associated with different financial conditions depending on where you're located. And that also means that the landfill mining in Europe is not comparable with the landfill mining in India, at least not in all aspects. We know that the waste composition is very different. We know that there are different standards and rules. European Union is very regulated when it comes to standards and common rules with the 28 European countries. Not all countries follow them, but if you go to the northern part of Europe, Denmark, Norway, Sweden, Germany, the Netherlands, we actually comply with most of the rules and try to follow them. Also, we see that Europe there's a lot of technology going on, especially in Germany and Netherlands. We constantly try to develop new recycling technology, sorting technology, and also we have a lot of waste to energy. And we have high standards on the pollution control in European waste to energy plants. As you also mentioned in the report, there are of course different solutions to treatment like gasification or pyrolysis, but it's not very common used in Europe for now. I would say that it's still in a startup phase when we talk about those methodologies. We see them. We have been discussing them for 15 years, but they have not actually been well proven in Europe. If we go to Japan, there are some well functioning pyrolysis plants that are well working. But Europe, we have some in some parts of Europe, but it's actually not very well known and used. Next one. So, as I told you, there are differences between the waste composition in different countries, and that's also what we can see when you sort out your waste. You get a different kind of material, or you get the same fractions, but you get a lot more RDF or fines than we do in Europe. You can take a look at where I come from. I feel that I'm representing a high income country, and you can see that this is actually what we produce of different material from municipal solid waste. And you can see that even though we produce a lot of organic material, 34%, we actually don't have any. We actually don't bring it to landfills. Maybe some European countries do, but in Denmark we only landfill approximately 1% of our waste that goes into the landfill. The organic material goes to biogas. The plastic go to recycling, glass go to recycling, metal recycling, and textiles. We have recycling opportunities for all different fractions. So more or less, what goes into landfills in Denmark and Northern Europe is more or less inert waste. So looking at landfill mining from a new perspective in Europe is actually not of very big interest. So if we want to do landfill mining, we need to go back and look at some of the old landfills from the 70s to the 90s. And I would say if we do a landfill mining project, this would probably represent what we can find in a European landfill. So yeah. Next one. Also, you can see that we talk about common rules in Europe, but we can also see that there are 28 countries, and there are very different rates of waste that goes into landfills. You can see where I come from, we only landfill approximately 1%, but there are countries like Greece that more or less landfill everything into their landfill. So in some parts of Europe, we still see the dump sites or big mountains of waste that could actually be processed like in India. Probably. So there are different ways of managing the waste within Europe. But the European Union is what he also told about from Norway. The European Union is trying to unite the way that we are managing our waste so that we have common criteria and common goals for our waste in the future. Next one. So what you can actually see is that the the European legislation actually have some targets for reuse and recycling of waste that says that we need to recycle or reuse minimum 60% of the municipal waste, and that means plastic, food waste, and etc. And only 10% should go into landfilling by 2035. So you can say that we are trying to make some strict rules that say we should minimize the waste that goes into landfilling, and actually go into the circular economy in a better way. Not all countries comply with it yet, but we are at least trying to make some common rules for all the countries so that we reach a common goal. Yes, next one. Also, as you said, that transportation is very costful in India. Of course, you are a very large country, a lot of inhabitants in the country. In my country, where I come from, we have high standards waste to energy plants. This is the one that I work from. They have the ski hill on top of the incinerator, and you can go skiing. It also can burn the waste, and it's located just outside of Copenhagen. As you can see, we are 5 million inhabitants in Denmark. The biggest transportation distance from the northern part of Denmark to the southern part of Denmark is like 500 kilometers, and you can see that we have more than 30 incineration plants. So the transportation of materials to incineration or RDF is actually not an issue in Denmark, and probably not in Europe. Also, the roads and infrastructure is very good, so that's actually not the problem. Next one. So you can say when we do the separation thing, it's actually the same concept as we use in Europe. The machinery, the separation system is actually the same. From our point of view, the SCF is not a problem in Europe. The construction waste, often we have recycling standards for inert waste. Often we have some problems with asbestos waste, problems with PCB or other substances that are actually inside the waste. So we have to analyze and see whether it complies with the recycling standards that we have in Denmark and Europe. And also the fine fraction, which you can use for different purposes. You can bring it back to the landfill, or you can recycle outside for road purposes or construction purposes. That's often the very heavy and problematic fraction, because we know that when it's been into a landfill for 20, 30, 50 years, we know that it contains a lot of materials, heavy metals, PCB, PFAS, and we have to comply with different standards in order to actually recycle the material. So often we have to bring it back to the landfill, and it's actually not possible to recycle the material outside a landfill. So often it's very expensive to actually sort out the material and then bring half of the material back to the landfill. So we can actually remove the contamination from the landfill. Otherwise, we have to bring it somewhere else, but then it doesn't matter. Next one. So what is actually the way? Of course, as we talked about, if you want to remove the mountains and not make the same mistakes, you need to have a better waste management system in place in the beginning, and you need to move away from landfilling. You need to go to, if you have organic material, don't bring it to the landfill. You need to make compost. You need to maybe put into biogas, or maybe burn it into a waste-to-energy plant. Of course, there are some problems with the moisture content often, but you can mix it with different types of waste. Also, RDF is actually a very high demand in Europe. In Denmark, where I come from, we don't have enough waste for waste-to-energy. We are constantly looking for opportunity of export of materials. You even get paid a high amount of money to actually take your waste. We receive waste from Germany. We receive waste from the UK, and we actually pay to get the waste. And it's mainly RDF is mainly consists of plastic material. Also, you need to build more waste-to-energy capacity. I know that is a problem because often some of your waste-to-energy plants are probably very old and not very efficient, and you don't have the same need for heat as we do in the northern countries. You can see that it's quite cold now. Our waste-to-energy can produce electricity, but it can also produce heat. So we need to go through the winter time and heat up our housings in Denmark. So we actually benefit from the waste to energy, and that's why we have so many waste to energy plants in Denmark. Also, the gasification and pyrolysis, it could be an alternative possibility, but it's not a mature technology, I think, and we only see a very few plants within the European Union. But of course, this is a possibility, and you can actually take out at least some of the plastics and turn it into oil or different material. And then also a good opportunity is actually to look for strong partners in Europe. They have a lot of good equipment and technologies in Germany and the Netherlands. And they are more developed on recycling technologies than we are in Denmark, especially when it comes to plastics and different recycling technologies. So it could be a possibility to look for strong partners within Europe to recycle or process more of your waste, so that it wouldn't actually have to go to the cement kiln at the end. So you could probably process more and get a good value out of this. So yes, that's it, I think.
Much, Rene. Thank you. We have exhausted our time. In fact, we have exceeded our time by almost 10 minutes. But I mean, I can see still a good number of participants are with us. We started at 3:30 local time. It's almost 2 hours that we have been discussing. I mean, it's fascinating because all the panelists have brought very different perspectives to this whole discussion, and it couldn't get any better. So just 5 minutes, some quick fire questions. I would request Dr. Tribhuvan and Dr. Richa, if you can just take a look at the questions in the Q&A box. I can see many of them has already been answered by some of the panelists. So if you can just take the question and direct them to the right panelist. We have Palasda, Varun, and Rene. And Dr. Richa, you can also take questions if you want. So over to you.
Atin, if I can just take one question, which is
Yeah.
no longer, I can see that in the chat box, but it was there like, and I know that there are people who say that, because when we say remediation, it means complete remediation, including the soil, the groundwater, which has already been contaminated. So first of all, the question was about why biomining is required. So I think we have enough scientific evidences reporting that there's so much pollution happening because of the open dump sites that we have. Now, we have to understand that our landfills are not scientifically constructed and operated. As a result, there is no sufficient mechanism and pollution control, mechanisms to see if the leachate is properly managed, the air emission is properly managed, and things like that. So I think it's not a choice for us. That's why the government has mandated the cities to do it appropriately. The other thing, remediation, of course, we are not checking if we are, how is the groundwater quality and what we can do to remediate that because of the cost constraints. But definitely, maybe in the coming SBMs, we will talk about those issues as well. But first thing first, I think it's extremely important to remove the source of pollution that is there in our cities, and then make a transition from this disposing of in landfill to scientific treatment. So I think it's a good way, and it's we should appreciate the good mission and the mandate by Swachh Bharat Mission 2.0. So yeah.
Anything, Dr. Tribhuvan, that you would like to bring in, like any question that?
So mostly all of the questions have been answered. However, I would like Mr. Varun to answer this one question by Siddhant. Are there any specific incentive schemes that processing companies can use since EPR have been largely idle? And what is the way forward for RDF in your view in India?
I think Varun may have but I can see him on the screen, but he may have left already.
Yeah, so basically, yeah.
Okay.
So most of the questions are already answered. So yeah, one question is like due to NGT from Deepak Yadav, due to NGT states are not accepting SCFs from other states, wherein the estimates considered by the corporation does not include this factor. How can we tackle these particular issues? So I guess Mr. Saurabh Palsania was the right person to answer this, but I guess he has.
Richa, would you like to take it, like even partially?
Could you please explain the question? I'm not able to. So the NGT states, what is that? I mean, like.
So, Mr. Deepak is asking that due to NGT rules, states are not accepting SCFs from other states. So
I see. So it's talking about the one state to another state movement of the. I don't know. I mean, I've seen many states or cities which are in, for instance, we were talking about Leh. So it is sending their way. They actually plan to send their SCF to other state. I think they have to take some permissions, etc. I'm not so clear about it. But yeah, it's quite possible. I'm not sure how NGT is intervening in that, because it's not something that will fall under transboundary movement because it's happening in the same country. I don't know if
we may have to get this information verified. Is there any other question, Dr. Tribhuvan?
So I think there's only one question to look. What is the product looks companies producing from the plant, and are they concentrating only on the dry waste? Rest everything.
I think we can write to you. Can we can just share the answer with the
Okay, I think
what we have seen is there has been interstate, as Richa rightly said, because there are few states like Uttar Pradesh, West Bengal, big states generating a lot of waste, but they don't have any clinkering plant, for example. So they have been actually sending to the surrounding states. But there is a stigma attached because of the hazardous waste, because the hazardous waste interstate transport is forbidden. So
but
it's a little bit of a gray area.
It will not fall under the category of hazardous waste management.
It will not, but it's the little bit, that's why you need little bit of, what should I say, awareness raising with the state pollution control boards and the municipalities, urban local bodies in that respect.
So I think there's one more question from Kuldeep. Kuldeep, please go ahead.
Not from me.
I mean, from the participant,
This question is from another party, and the question is there evidence to show that EPR rates for end of life of fresh waste has come down ever since cement plants started getting EPR for legacy waste? From her experience, the rates have come down from 5 to 6 rupees per kg to 1 to 1.5 rupees per kg now. So, Richa, would you like to answer this question if you have the experience of this Prayagraj model?
And also, Palasta, if you can throw some light, because this is very interesting.
So that's
after you.
No, I think that's a very good insight. But as far as I know, that the cement industries are actually looking at much higher price when it comes to the credits. But I would just take it as a very good insight. I was not aware of this.
Yeah, even I was about to say the same thing. In fact, in my opinion, I'm seeing the SCF, which is derived from legacy waste dump sites only. So don't know how to compare that. I mean, yeah.
Thank you. All right. We are almost 15 minutes past the schedule closure, but I have no regret because it was absolutely fascinating. We have recorded it. So those who have missed it, will upload it in our website where the announcement is the page that you had to visit for registration. And we'll try and collect the presentation that are not available with me right now. I already have presentation from Palasda, Rene, and Richa, but rest of the presentation I'll collect and I'll upload in the site. Yes, Richa, go ahead.
Then before we leave, just want to thank Palash sir for highlighting one major issue in my first slide. So I always goof up about this, goof up the things related to the unit. So it was not million tons, it was lakhs tons.
Yeah.
There's always this conflict of matrix between India and
we suffer the same between India and this comma and the decimal.
Especially after coming here, I have to convert the values into million tons, not constantly training myself not to use crores and lakhs anymore.
And thank you, Dr. Richa. Thank you, Palasda. Thank you, Rene. And thanks to Barun and all the other panelists, Saurabh sir, Ashish sir. It couldn't get any better. And thanks to all the participants for being so patient and asking loads of questions. And thanks to Dr. Tribhuvan and Kuldeep who attempted answering as many as them as possible in the chat box. So we'll definitely stay with the agenda. We'll look forward. Richa is no longer with CSE physically, but she's with CSE otherwise. And Richa's research, even current research, is also benefiting us, and she has been a great company and great friend. So thank you, Richa. Thank you for your effort. And
Thank you so much, Atin. Thanks, everyone.
Even after you left CSE. So thank you for finishing the study, and thanks, Rene, and thanks everybody for the wonderful discussion, for the wonderful insights that you brought on the table for all of us to learn. And couldn't get any better. So from CSE, thanks to all of you. Please take care and stay safe. Thank you so much.
Thank you.
Bye.
Thank you all.
Bye-bye.